Alrighty, this is video 8.8, and we're actually going to use our formula, which is our scale factor squared is equal to the area of a similar two-dimensional shape divided by the area of the original. Now, I think I've said this before, but I want to bring it up. In math, similar is like it has more meaning than it does in real life, right? In real life, you could say, hey, that must be your sister, you two look similar. Okay, but in math, it means that the sides are all in proportion and the angles are all exactly the same. It's a little fussier. All right, so anyway, Jasmine is making a kite from a 2 to 25 scale diagram. The area of the scale diagram is 20 centimeters. How much fabric will she need for her kite? Well, here is our scale. So K squared is area of I don't know what to write. As you know, 2D shape over area of original. All right. Now, K squared, that's going to be 2 over 25 squared is equal to, now, it says the area of the scale diagram is 20 centimeters. So that's going to be 20 over x. That's what we're going to solve for. Sorry, I should have left myself way more room. So if we're going to square this, okay, it's going to be like 4 over 100, but we can go 2 divided by 25. So 0.08 squared is equal to 20 over x and times 0.08. Oh, my mouth was off there. Somehow that doesn't seem right. Let me try that again. 2 divided by 25 times 0.08. Yeah, all right. So 0.064. Oh, I lost a 0 there. Equals 20 over x. Now we're going to cross multiply. 0.0064 x. Oh, I have to put a 1 there. Is equal to 20 times 1. Yeah, I'm really regretting not leaving myself more room here. So 0.0064 x is equal to 20. We're going to divide that out. $20 divided by 0.0064. Woohoo! 1, 3. Ah! You're staring at, and I'm staring at, and I'm still writing it backwards. 3, 1, 2, 5 centimeters squared. Okay, so how did I know where to put this stuff? Well, let's look at our final answer. She's got this small, she's got a scale diagram. Her kite is clearly going to be bigger, right? Because this is saying, because this number is actually less than 1, like it's 0.08, that means this is a smaller version of it. So the 20 has to go on the top, and the area of the original is on the bottom, and this makes sense, okay? And how much fabric will she need? She'll need at least that, plus, anything, I don't know how she's putting it together, but she's got to be gluing it or sewing it or something, so she'll probably need even more than that. All right, ta-da, there's our question. Let's try the next one. Okay. Jim's laptop monitor has dimensions of 9 by 12. The image on his laptop is projected onto a whiteboard. According to the documentation for the whiteboard, the screen area is 2000. Oh, okay. The image on the whiteboard is similar to the image on the laptop. Determine the scale factor used to project the images on the laptop onto the board. Okay, so scale factor. Boom. we know what we're doing. So k squared is equal to area of 2D over area of original. Well, what are we going to call the original? I think it sounds to me like it should be this one. And this is the tricky part in the question. They don't tell you what the area of that is. So k squared. I'm going to go area. I'm just going to do it right here. Monitor is length times width, which is 9 times 12, which should be 108, but whoopsies, 9 times 12. Whoop, yep. 108 inches squared. All right, so 108 inches squared. And then what we projected is 2836.6875. That seems way too specific for a whiteboard, but whatever. All right, so k squared. Okay, 2836.8, whoops, 6875 divided by 108. All right, so k squared is 26.226. I'm just going to write it all down. I'm not going to worry about it right now. I'm going to do square root and square root. You guys all know that, right? You just turn your calculator sideways and you can get the square root button. And I get 5.125. So k, 5.125. Now, before we go further, does that make sense? Okay, so he's got his laptop. It's being projected onto the wall. That second one is bigger. So my k has got to be bigger than 1. It's like that question we did previously where we had a diagram of a cell. All right, so there is my scale factor. So this is now determine the dimensions of the whiteboard. I think there's a bunch of ways to do this, but maybe the easiest is all we have to do is take the measurements and multiply them by our scale factor. So 9 times, so this is B, 5.125. Oh, I probably should have used a formula for that. You're going to see it's going to work out like that. Well, we've got k. Now we're talking linear, so it's the original, and in this case, you know what, let's make it even better. Nope, nope, nope. Whiteboard on top. Monitor. We know what k is. 5.125 is equal to whiteboard, getting bored, over 9 inches. So put that over 1, and 1 whiteboard is equal to 9 times 5.125, which I said previously. Or possibly it could be one of those, you just think about it, my calculator, and go, well, of course it has to be bigger, so I'm going to multiply. But this proves why you're doing that. It also helps you on the days where you're like, I'm kind of lost, I don't know what's going on. All right, 46.125. Inches. I'm not going to bother with the equation for this one. For the other part, I'm just going to go 12 times 5.125. 61.5 inches. And then let's do a quick check. 46.125 times 61.5 times, where are we, 46.125, and we'll get 2836.6875 inches squared, which that's what we were supposed to get. So we are golden. Okay. I guess another option could be you could have done one of them, so gotten the width and then taken the area and divided it out. Okay, I'm fussy. I liked my method because I did it twice and then I was able to do a check. Okay, it's a little more backwards, check the other way. Excellent. Oh, but wait, there's one more at the corner here, or at the bottom. Determine the area of the shaded region. If both radii double, what happens to the shaded area? Well, another thing that your textbook just assumed, well, I think it's in the textbook somewhere. Area of a circle is equal to pi r squared. Okay, and I just found out if I turn my calculator sideways, I have a pi. So what we want to do to find that shaded area is we're going to find the area of the big one, and then what? Exactly, subtract the area of the smaller one. Okay, so area is equal to pi times 2 squared. Area is equal to pi times 4. Right, I'm going to use my pi button because I have one. And look at all those decimal places it gives me. If you want to use 3.14, I'm sure it's fine. Times 4. Okay, because I'm going to round it right away. 12. Please don't ever be the person that writes all those decimal places for me. Let's go 2 decimal. 5, 7 centimeters squared. What's your units? Right, that was centimeters. And it was centimeters twice, so that makes centimeters squared. Or area is always centimeters squared. And now we'll do small. And area is equal to pi times 1.2 squared. 1.2. Ooh, I have a squared button. 1.4. So we'll just multiply that by pi and hit my equals. So 4.53. So the ring will be 12.57 minus 4.53. Okay, 8.04 centimeters squared. Now, instead of both radii double. So let's make this double. Hey, now would be a really great time for you to turn off the video and do this part by yourself. So the big one is now going to be 4 centimeters, and the small is going to be 2.4 centimeters. So area is equal to pi r squared. Area is equal to pi times 4 squared. Area is equal to pi times 16. So pi times 16 is 50 point, let's go to 7 centimeters squared. And our small one, area is equal to pi r squared. Sorry, zoning out, enjoying my math, and probably my voice is starting to get soft. Area is equal to pi times 2.4 squared. I don't know what 2.4 is. 2.4 squared. All right, so area is equal to pi times 5.76. So we'll just go times pi. Oops, equals. Area is equal to 18.0. Uh-oh. Okay, so 0.9, but that 5 makes a 9 go up, and that makes a 10, so it goes up, so it's actually 0.10. And let's take a look at the difference. So our ring, again, is going to be 50.27 minus 18.10. 50.27 minus 18.1. 32.17 centimeters squared. Now, does this follow what we've been talking about? What did we do? We doubled our length. Well, if we double our length, our area, should be 4 times as much. So if we take the area of the smaller one, 8.04, and we multiply it, we said it should be 4 times as much. Woohoo! That almost. And the difference there is just rounding error. So that is pretty cool. So not only is it the nice squares that we looked at the beginning, the equilateral triangles, it even works for rings. So very, very cool math.